Santham Academy. Welcome to Digital Kaksha. To get updates on new videos, click the subscribe button and the bell icon.
Let us study about the electrostatics of conductors. There are certain points, certain properties which are to be discussed when we are talking about the charged conductor. The first property is the electric field is equal to 0 inside the conductor which is charged. Let us say here this is a conductor, a spherical conductor. When this spherical conductor is charged, all the charges are present on the surface of the conductor, or we can say that the electric field inside the conductor is equal to 0. That is to be understood. Why is it so? So, if we assume that the electric field inside the conductor is not equal to 0, in that case, all these charges which are present on the surface of the conductor and which are the static charges, they will experience the force. The effect of the force on these charges, it will be that due to that force, these charges will start displacing from their position. But in the static situation, it is not possible, or the charges are static at their places. That is why the supposition which we are assuming that the electric field inside the conductor is non-zero will be proved to be wrong, and on this basis we can say that, or we can understand that there is no electric field present inside a charged conductor. The second property is that the charge inside the conductor is equal to 0. When we have understood in the first property that the electric field inside the conductor is 0, so that means there cannot be any presence of charge possible inside the conductor. The third property tells us that the potential inside the conductor is constant at every point. In order to understand that how we will get a constant value of potential, we will be using the relation between the electric field and the potential. So, using the relation, E is equal to minus dV upon dr. From the first property, we know that if electric field is equal to 0, this will be substituted in this relation. So, it implies that minus dV upon dr is equal to 0, or dV upon dr is equal to 0. When the differentiation of the physical quantity with respect to any physical quantity is equal to 0, we can conclude that from this expression that V is equal to constant, because we know that the differentiation of a constant quantity is always equal to 0. Coming to the next property, which is called as electrostatic shielding. The meaning of the word shielding is protection. So, electrostatic shielding is the phenomena of protecting any region from the presence of electric field. So, one of the example for understanding the electrostatic shielding is that during the time of the lightning or the thunderstorm, it is always safe to remain inside the closed car. As the body of the car is made up of metal, so we are safe inside the car as the presence of charges will be possible only on the surface of the metallic car. Now, let us study about dielectrics and polarization. The non-conducting substances or materials are called as dielectrics. They don't have any charge carriers, or even if they have, these charge carriers are negligible in number. This diagram is representing the case when a dielectric is kept in an external electric field. Here, E0 is representing the external electric field. In this case, the molecules which are present inside the dielectric, the charges of those molecules are separated. The negative charges are shown here, and here these are the positive charges. The separation of these charges we will be studying in detail by using this diagram. Now, because of these charges, separation of these charges, an electric field is induced inside this dielectric, which is marked as EI. Since the direction of electric field is from positive to negative charge, so in the figure it is very clear that the directions of two electric fields E0 and EI are opposite to each other. But the sum of the electric fields, that is E0 plus EI, is not equal to 0. Whereas when a conductor is being taken and this conductor is kept in external electric field, after the separation of the charges, here also the electric field is induced, that is represented as EI, and the value of the sum of E0 and EI, in this case it is equal to 0. These diagrams are the representation of the cases when the dielectric and then the conductor one by one are kept in the external electric field E0. Now, let us understand what exactly is happening when a dielectric is kept in external electric field. In this diagram, a dielectric is kept in the external electric field E0. The direction of the external electric field is marked in the diagram from left to right. The circles which are drawn in yellow color are representing the molecules which are present in the dielectric. Now, due to the presence of this dielectric in the external electric field, what is happening inside every molecule of the dielectric? As you can see in the diagram, the positive and the negative charges are separated. Now, when this separation of the charges it is being shown, these negative charges have a strong bondation with this surface, and these positive charges have the strong bondation on this side. Except the negative charges on the left side of the dielectric and the positive charges on the right side of the dielectric, rest all the positive and negative charges are getting neutralized. So, the accumulation of positive charges on the right side of the dielectric and negative charges on the left side of the dielectric results in the development of the electric field inside the dielectric, which is called as the induced electric field and can be also represented as EI. So, this is the reason why inside the dielectric, the electric field is induced in the opposite direction of the external electric field. When these charges are getting separated inside every molecule of this dielectric, the same separation of the charge is taking place in the complete volume of this dielectric. As we are already knowing that when the two equal and opposite charges are separated by a small distance, that system it is called as the electric dipole. So we can say that the molecules of the dielectric behaves as the dipole. Now this every dipole will be having the value of the dipole moment. This way the dipole moment is induced in the complete volume of the dielectric, and this induced value of the dipole moment in the complete volume of the dielectric is termed as the physical quantity, which is called as the polarization. So the definition of the polarization can be given by the induced dipole moment per unit value of the volume of the dielectric. Since we know that the SI unit for the dipole moment is Coulomb meter and the SI unit of this volume is meter cube. This way the SI unit of this quantity polarization can be written as Coulomb per meter square. This SI unit is same as that of the SI unit for the surface charge density. The polarization is also given as P is equal to chi e into E, where chi e is called the electric susceptibility of the dielectric medium. This electric susceptibility or chi e is the constant characteristic of the dielectric. So in this video we have talked about basically the property or the behavior of the dielectric when it is kept in the external electric field. I hope you have understood the topics which are discussed in this video. Thank you all for watching the video.
Thanks for watching. If you like this video, make sure to like, share and subscribe for more.